In this lesson, we will simplify polynomials and then classify them based on degree and number of terms. So let's start by talking about what it means to simplify a polynomial. Typically, when we simplify, there's a few things that we want to accomplish. No more parentheses. All like terms together. And we want to write our answer in standard form where applicable. So, in some problems, there are parentheses, like the second problem that you see here in the what to watch. But in other problems, there aren't any parentheses to get started, like in the first problem. So if there aren't any parentheses, or if you've already gotten rid of them, then your next goal is to get all the like terms together. So let's remember what like terms mean. Things have like terms if they have the same variables with the same powers. So as we start looking at this first one, I see a 3x term, and as I keep looking, I also see an 8x term. So those are like terms. I have 3 x's, you give me 8 more x's, that gives me a total of 11 x's. And then I see that I've got a negative 6y and a positive 2y. Those are also like terms because they both have a y with a degree of 1. Well, negative 6 plus 2 is negative 4, so that means we have negative 4 y's. And then there's that plus 6 with nothing to combine to, so we just write plus 6 at the end. Now let's talk a little bit about writing our answer in standard form. Standard form mostly applies when we have only one kind of variable, like only x's in our problem. But we still consider standard form a little bit, even when there's different variables like the x and the y that we see here. Typically, if we have more than one letter, then we go in alphabetical order, which is why you saw me put the x term before the y term. And typically, we still try to put higher powers first and smaller powers last, which is why the terms with the variables came first, and the term that was just a number came last. So this is actually as simplified as that particular problem can get. So now it's time to classify based on degree and number of terms. Well, when we're classifying based on degree, we're going to start out by looking at the degree of each of the individual terms. So if I look at 11x, that's like having 11x to the first. So the degree is 1. Then I look at the next term, negative 4y. That's also like to the first. So it also has a degree of 1. And then the last term is 6. Now, there's no variable written there. So it has a degree of 0 because there are essentially 0 variables. So the highest degree that we have present is 1. There's a degree of 1 on the x and a degree of 1 on the y. So this whole polynomial is said to have a degree of 1. Well, a degree of 1 is a linear polynomial. So we're going to classify this thing as being linear. So let's look at these classifications. See, we have on the left, a degree is all of these different classifications. A degree of 0 is called a constant because the value is always the same. It's just a number. A degree of 1 is linear. A degree of 2 is quadratic. Of 3 is cubic. Of 4 is quartic, like having 4 quarters in a dollar. Of 5 is quintic. And then those are the only vocab words we're going to learn. Anything with a degree higher than 5, we'll just refer to it by its number, like 6th degree, 7th degree, 8th degree, etc. Then we have this other set of vocabulary based on the number of terms. So when there's just one term in a polynomial, we call that a monomial, like a monorail only has one rail. A binomial has 2 terms, like a bicycle has 2 wheels, and a trinomial has 3 terms, like a tricycle has 3 wheels. If it has more than 3 terms, we just refer to it as a polynomial, but then we specify how many terms it has. So as we look at this, see how there are 3 terms. The 11x is one term, the negative 4y is another term, and the plus 6 is a third term. So we will call this thing a trinomial. So when we classify it based on its degree and number of terms, it's called a linear trinomial. Let's do the second problem. In the second problem, there are lots of parentheses, and I mentioned earlier that one of our goals is to get rid of parentheses. So it's important to realize which parentheses do something and which don't. So the parentheses around the 2x plus 1, they really don't do anything at all. Nothing's multiplying that. It's just naming that as being the first binomial. So I actually can take that straight out of parentheses. But the second set of parentheses is doing something. It's telling me that I have to subtract all three of these terms. So that 3x cubed is being subtracted. Now when I subtract a negative 2x, I've got really a positive 2x. And when I subtract a positive 5, that looks like minus 5. And then the same thing happens with the next negative sign and those three terms. It's telling me to subtract all three of these terms. And I will have fixed this by the time you get your note sheet, but mine has a typo right here. That should say 2x in there. So this is negative 5x squared minus 2x minus 1, because each of those terms was positive. So when you subtract them, they become negative. And then that negative 8 is not affected by anything because it's not in any parentheses. So it's just a negative 8. And now we're going to do like we did before. And we're going to go ahead and we're going to look for like terms. So I see a 2x, another 2x, and a negative 2x. Those are all terms that just have an x. I see the number 1, the number negative 5, the number negative 1, and the number negative 8. So those are all like terms. Let's see what else we have. I see that we have a negative 3x cubed, and I don't see anything else that has an x cubed. And I see a negative 5x squared, and I don't see anything else that has an x squared. So some things don't have any like terms to combine with. So here's where that idea of standard form comes in. Anything with a high power wants to come first, and anything with a low power wants to come last. So the highest power I see is a 3. So this negative 3x cubed is going to be our first term. Our second term will be that square, negative 5x squared, because that's the next highest term. But the next power is 1, and I see a 2x, and a negative 2x. So 2 plus 2 is 4, minus 2 is 2. So we're going to have plus 2x when we combine those like terms. And then 1 minus 5 is negative 4, minus 1 is negative 5, minus 8 is negative 13. So this has been simplified and written in standard form because the highest powers come first and the lowest powers come last. And now we need to look at each term again to determine the degree. So we have negative 3x cubed, which has a degree of 3. And we have negative 5x squared, which has a degree of 2. We have 2x, which has a degree of 1. And we have negative 13, which is a constant. It just has its own value. There's 0 variables there. So that has a degree of 0. So when we go to classify this thing based on degree and number of terms, that degree of 3 kind of wins the day. So we would call this a cubic polynomial in 4 terms. Notice we had to say a little bit more because if there are more than 3 terms, we're just going to call it a polynomial, not something specific that tells somebody how many terms it has. So we have to add the phrase in 4 terms to the end. So this is a cubic polynomial in 4 terms.